All right. A bit echoey. Hello, hello. Okay, let's try. So, welcome to the talk about Java util concurrent flow, what was previously known as reactive streams. And it's going to be both a quick look back at what it actually... Am I echoing or just to me? Okay, so it's just me that hears the echo. Okay, so let's dive right in. So my name is Konrad Malawski. I work at Lightbend, so a company behind Scala, Akka, Play, Lagom, distributed microservices, and basically the Scala programming language as well. But all of our APIs have a Java API, which I'll talk about a bit, but not too much. And I also did the Reactive Streams Tck. So you'll see what Reactive Streams actually is. It's not something you can pick up and use. It's more of just a standard. And we'll talk about why would you care about a standard like that and how it actually came to be. Other than that, I do a lot of community stuff in Poland, like Geekon conference, like 1,200 people each year. The Polish Java user group, I founded the Scala user group, like white paper reading clubs, things like that. Anyway, so the usual question on conferences, who has not heard of Akka? Like hands up, I won't be offended. Okay. Who has heard and maybe even used it? Oh, cool. Okay. So people, last question. So who has heard about reactive streams? Okay, so you know about reactive streams. So we'll see how much we can skip or how much not. But Akka is a bit more than that. We do distributed computing. Yeah, by the way, we have the Akka Streams implementation, which is a reactive streams implementation. We also have an HTTP2 server, and of course the distributed cluster. So, brief reminder for people who don't know what Akka is. That's a number of the tools we have in the toolset. And we're pretty much pick and choose. If you just want to use Alpaca, we'll talk about Alpaca today. That's like an integrations thing. Also streaming, which is why it fits into today's topic. You can just pick that. You don't need to do the actors or clustering, and vice versa. So, basically, end of corporate pitch. Let's talk tech. So, stream is probably one of the most overloaded terms right now. Everything is streaming. Even if it isn't streaming, people call it streaming. A good example would be Spark streaming, which is kind of streaming, quote unquote, but practically speaking, it's more mini batches, and you get very different semantics between all of the different libraries which claim that they're streaming libraries. You get the more big data oriented things like Spark, Flink, whatnot. And then you get things like reactive streams, which is more on the level of like an input stream. Right? Sometimes people ask me to compare reactive streams with, I don't know, Spark streaming, right? That question doesn't really make that much sense, because how would you compare, back in the old days, compare Hadoop to input stream, right? Not quite the same thing, even though, okay, both have a similar concept, thing goes in, thing goes out. So, this is a bit of terminology, and then we'll jump back into the past to see where it all came from. So this is Akka Streams terminology. We call things a bit more specifically than some other libraries on the same level. So an example would be RxJava, for example. They talk about observable, and everything is an observable. In Akka Streams we have source, flow, sink, and it depends how many inputs and how many outputs it has. So it's a bit more in your face, but this is for consuming data, or this is for transforming data, etc. And we have asynchronous boundaries, and this is where reactive streams is actually meaningful and useful, and what we'll talk about today. So the asynchronous boundaries between these processing elements, each of those could be actually a different technology. So it doesn't have to be Akka streams. And back pressure. So that's the two main features of reactive streams. It has flow control, so it prevents out-of-memory errors like that. And it's a standard, so multiple libraries can interrupt between each other. But I want to fast forward a bit and talk about the second most overloaded word on the planet right now, which is reactive. To that point, overloaded, that I wrote a mini book to kind of clarify what reactive really is. And it's not just reactive streams, which many people will want you to believe right now. It's a bit more than that. If you remember the Reactive Manifesto years ago, that's at least how we think about it. By we mean, well, Akka people, Lightbend people. We think it's a bit bigger than just reactive programming. So the FRP style, RxJava, Akka Streams style. That's a nice building block, but that's not the entire story. It won't help you achieve the end goal that we had in mind when Victor kind of initiated the Reactive Streams thing. Okay, so reactive apps, awesome, absolutely. Topic of today's talk, not the entire thing. So there's more stuff to add. Things like resiliency and being able to scale out or down, that's also part of reactive systems. At least how we defined it back then in the Reactive Manifesto. So, why did we actually set out to do the reactive streams? People here have raised their hands that they know what reactive streams was and is. But why did it actually come into our minds that we need this thing? So basically, in my team, we would have a lot of customers that come in to us and basically would be a project rewrite or a greenfield, and they want to use some reactive technology. They pick Akka, they rewrite the system, or they write the new system, and it's super awesome, handles traffic like a boss, great, has even sunglasses. Everyone's happy. They put it through load testing, everything's fine. They put it in production, it integrates with other systems, and the other systems have either not been modernized or just are even not under your control. It could be a third party or something. And some of them don't really handle that new traffic you slam at them. And it ends up like that. So it was really driven by a need that, okay, on one hand, it's great that our app is so fast and that we can claim to people, look at Akka, so fast, so great. On the other hand, we want to integrate nicely with the rest of the planet, right? We don't want to keep crashing the rest of your company by overloading them, just because we can process things faster than some other system. So that's the prime need for flow control, etc. Specifically in asynchronous programming, so the Akka toolkit is all about asynchronous programming. Just adding flow control to a thing isn't as trivial as it is in a blocking application. Because in a blocking application, you're basically automatically being slowed down because you're blocking until someone has processed the write, right? In an asynchronous app, you kind of can keep going even while the thing is not done processing on the other side. So this is the kind of immediate need that we wanted to address like 3 years ago or something. Nowadays, there's a funny pattern that we see from people. I'll just slap a Kafka in there, it'll be solved, right? And I found that very funny because an author, I think there's 2 authors in that book, and he tweeted that one issue that keeps coming up with Kafka Connect, so that's the kind of system where you want to like drain from a database into Kafka, or the opposite. Many downstream systems don't scale as well as Kafka. Sounds familiar, right? Same story. New tech, faster than other systems. Other systems still valuable, maybe probably even making money. Your system not even yet making money because not in production. So, you know, it's a bit hard to argue. And if there only would be a way, and here I'm hinting at the Alpaca project, which you will see what it's all about. It's basically about integrating these various technologies without having to lock you in or be very specific about, oh yeah, we only like these technologies, we don't like that technologies, kind of like camera, but we'll get to it. So, this is the immediate need we kind of wanted to address. Reactive Streams starts 3 or so years ago. So, the reason I talk about this stuff, and you see me talking about it, so I did the TCK there. So the set of tests that verify if you actually implemented it correctly. And you'll see why that actually matters. Because nowadays it's part of JDK9. And that's super cool. We're super excited about it. It was included via Doug Lee and the JEP 266. So the more concurrency updates. Lots of very interesting things there. But one of them being reactive streams, basically copy-pasted and renamed to Java util concurrent flow. But all of the semantics and rules about how they behave are the same. Remember that. That's kind of an important point. So it's exactly reactive streams, but okay, it's not the exact types. So now we'll have to have some period of time where libraries will have to support both, right? Because we wanted to build an ecosystem, kind of prove to Doug and well, the Java ecosystem that, okay, this is valuable. And now we'll have to kind of port all of this to the Flow interface. Should be pretty easy though. So if you're curious about, can you already today use the Flow interface to integrate things? Absolutely. We support that already in Akka. We just released a jar that can integrate with Flow interface, and at the same time you can still integrate with the Reactive Streams interfaces. So technically it's a breaking change because package rename, but practically you won't feel any pain from that. So it's more of an SPI, by which I mean to say that it's this integration thing, right? You have these various technologies, and when we did Reactive Streams, we invited the Spring people, so Project Reactor, well, Spray people, that's a bit Scala ecosystem specific. The RxJava project, of course, with Ben Christiansen, was on board from the very beginning. From Red Hat, we had Vertex, and all these different vendors that kind of solve the same problem. And we decided, okay, let's band together, build this thing, and then we'll all benefit. Instead of having everybody to lock into their ecosystem, let's build a bigger ecosystem that's going to be beneficial to everyone. So, I think I'll fast forward a bit through the history here. But like I said, 2013, we had kind of three parts to it. Play, so the Play framework had introduced a back-pressured API in Play called the iteratees. Back then it was, you were thinking, okay, maybe that's going to solve it. Practically speaking, it was way too complex for end users to be nice to use. We had a nice I/O layer, but none of these APIs were a nice API to work with. So what Ben Christiansen brought up to the table was, with RxJava, a nice API to work with, around which we built then the concept of back pressure, which RxJava didn't initially have. Then they added it kind of during this work together on it. Anyway, so that's the iteratees. If you quickly look at it, you can kind of imagine it doesn't speak to you in 5 seconds what it actually does. So that's why we scraped that. It would solve the problem of flow control and back pressure, but it was very Haskell inspired and didn't quite feel as native to Java or Scala developers. So we sacked that, and then this interaction began of kind of nailing down what we're going to solve. Talked about that already. And then finally it gets included in the JDK. Hooray! So, where does that leave us? It leaves us with these interfaces currently in the JDK, which you can use right now, but I'll ask you to not implement them directly. Because when you look at them, it's basically 7 methods or so, 4 interfaces. It looks very simple, but as any concurrency thing, it has a lot of implications when and how you can invoke things, right? So that's the actual complexity of reactive streams. That's the spec. I can zoom in on some random rule and let's try to see. That's not interesting. Oh, for example, a subscriber must be prepared to receive a non-complete signal with or without proceeding request call. So we can complete with an empty stream, for example, right? Seems obvious, but if your kind of implementation assumes, oh yeah, there's always going to be a request before a complete signal, well, you would be wrong. So rather than implementing it directly, I'd recommend using an existing library. Can be Akka streams, can be any of other implementations. The JDK ships with one example publisher. It's not very powerful, but you can get started with it. So let's explain reactive streams in a single slide. The protocol is actually not very difficult, and we settled on the naming publisher and subscriber. Was a big naming debate back then, so it's not PubSub. That's kind of my problem with the current names. When you say publisher, subscriber, people think PubSub, right? Makes sense. But it's specifically a point-to-point protocol, right? You can do a fan-out thing using this protocol, but then each interaction is going to be adhering to this kind of rules how to interact. It's not defined on the set of subscribers, it's on a point-to-point basis. So, since we aimed to solve the flow control mechanism here, and it's obviously going to be asynchronous, that's the purpose of it. So, usually you do have some kind of buffer in your system that's drawn here as this small shape. And you're processing some messages that's going on asynchronously. You have some things buffered still, and you have some free space in your buffer. If you think you don't have a buffer, you have a buffer somewhere anyway, because either it's going to be network or I/O or something somewhere will have some buffer space in an asynchronous system. So let's say we define that we talk about elements. So unlike TCP, we don't talk about, okay, give me this many bytes from this infinite stream of blob data. We talk about specific elements. So it could be person. Right? Give me one person, give me 3 persons. So here the green arrow says, I'm requesting 3 elements, which also can be said as, I am prepared to accept at most 3 elements. Right? Because you kind of know your buffer space, you see, okay, if you give me 3 elements, I will not blow up. And the upstream, so the publisher, even though it can be faster, it can never signal more elements than it was kind of asked for. And this basically, and a rule that requests kind of add up, but basically solves this simple flow control problem. There's some edge cases around completion and cancellation, error handling, but that's why we have the spec and TCK. So like I said, ships in Akka already, so you don't have to wait to adopt it. Pretty happy that we were able to pull that off. Didn't really need multi-release jars to that. If someone's thinking about how do people adopt this thing, for introducing new API, multi-release jars are not that helpful. Very helpful for changing implementation. For example, if we had been using some unsafe features, now we can move on to other alternatives like var handlers, etc. But for introducing new API, if you produce libraries or if you consume libraries, that's not the tool that helps you out with that specific case. So it's just a normal jar that was linked towards the JDK9 class. So interop in action, does it actually work? Just a quick example that across a number of implementations just works. It's kind of boring to demo these things and show these things because it just works, but that's the feature. So, a bit more Akka streams. So we had a brief look at kind of diagrams, but let's look at code. And I used Java here. Some of the slides will be Scala, but you'll notice that the APIs are very, very similar. And especially with the Lambda support since Java 8, it's getting more and more similar. So I'm pretty happy about that. As you can see, we have sinks, flows. So flow is like a function, basically. And if you're curious about why do we have 3 type parameters here in the flow and 2 in the source, that's basically because we found that very often you need to interact. Okay, within the stream, it's easy, right? You do your stream processing operations, you forward, you reduce, you map. But very often you need to either inject some control from the outside world or some observability, like a gauge, like a rate meter, or like a throttler that you want to control from the outside. So we have that in a type-safe fashion, but each stage can produce some kind of value that is then typed, you have it in your hand, and you can do stuff to it. We have a special type called not used that you can more nicely express that, okay, I'm not using this type parameter, rather than sticking void everywhere. This was something that we didn't like in many Java APIs, that when you didn't use a value, you just use the void, uppercase void, which felt a bit weird, so we have the not used, and we have a done type. Again, same thing, doesn't carry any meaning other than being easier to read. So if you get a done value, the stream has completed. And a big difference from other Reactive Streams implementations, we have a lifted representation. So that means by this time you have a source via flow to sync. It hasn't run yet, and only runs when you well, run it, or how we call it, materialize, which allows us to do some interesting either merging of multiple stages into a single stage and having that more configurable than not lifted implementations. So here's an example of getting this materialized value out. The sync head is basically a sync that materializes a completion stage. And here you can see, okay, so we run with this sync, and it gives us back this completion stage, which is what I talked about. This integration with the non-streaming world is pretty important, and here's something that we build in this way. Other ways to do that would be more side effecting on the side, setting something. We thought that's a bit more clear. This you've seen already. We have source flow sync, but you can have arbitrary many ports if you want. Okay, so that's, I think, the last talk about Akka streams at all. I just wanted to explain the building blocks we have, so you think about it in terms of sinks and flows and sources, because the entire future of reactive streams and Java util concurrent flow is in providing building blocks. Okay, so if you have these building blocks and you know that you're not locked into a single implementation because they all interrupt, you can start thinking about really picking and choosing parts of your streaming pipeline from whatever library is out there, and most of them are slowly converging onto these types, so we have a nice growing ecosystem. And we can nicely encapsulate them. So for example, if you have, to explain these, yeah, for example, like that, you can have some kind of flow that just processes and acts things from Kafka, and that's maybe from a database. You don't really care, it's the blue thing. And on the left-hand side, that's your logic, would be in an application, Akka streams terminology, a flow, flow terminology, that's a processor, one thing in, one thing out. And you can easily replace that, for example. This is slightly mind-bending once you see it just in normal daily code. On a picture, I don't think it's so mind-bending, so I keep showing this picture. You can replace a function with kind of a conceptual function, a flow, with independent sources and sinks. And that's actually very, very interesting, both for testing or, for example, you're injecting some test data with your source, but the sync side is still your actual logic, and instead of emitting data from your actual logic, you emit it into some assertion collector. And then this assertion collector, you just plug it a bit differently together, and you have this nice power of composability without having to change your actual logic. And it's all streaming still, because we have this abstraction that allows us to do that. So, now, if we talk about building blocks, this is the moment I want to talk about the Alpaca project, which I think is the important bit, because I talked about, okay, library interop, and that's nice, certainly. If you can kind of be assured that you're not going to be locked into Akka or spraying or whatever, or here specifically with Alpaca, you can just use whatever connector, that's all streaming connectors, including some IBM technology, because we partnered up, so there's some Azure, I forgot the names of the technology, Jesus Christ. They have an S3 compatible API, which was actually very funny to work with, because we thought we will have to write a specific endpoint to this IBM S3-like API, but turned out they were very compliant with S3 API of Amazon, so actually we just reused and shaped up a bit the S3 connector to be also able to work with that API. And that's interesting because you don't have to care. As user, you just look at the list, okay, does Alpaca have my favorite technology? You use the thing, and it's a streaming connector to whatever favorite technology you have there. And if you don't, then building it is pretty easy. And you can build it using whatever technology you want. You can use Akka streams, which I would highly recommend, but you can use anything else. As long as it passes the TCK, it's a fully streaming and safe thing that fits into this ecosystem. So instead of being super competitive and like being very aggressive about, yeah, we have a connector for this, we have a connector for that. We kind of invested in a more helpful environment where if anyone produces a driver, like MongoDB did a Reactive Streams driver, everybody can use it directly. And how does this grow? That was a few months ago, just a number of connectors there. Some of them we implemented, some of them just people in the community implemented. And this is today, and it doesn't even quite fit, so I had to make the text quite smaller. So we have a lot of things, including Lambda, S3, SNS, SQS, so a lot of Amazon stuff. Some Google APIs, which are equivalent to the Amazon things. And here the interesting bit is, okay, if you kind of abstract away your use of client library of specific cloud, I don't know, let's say this messaging API, then you can more easily swap it out if you want. So again, we're kind of helping you to be more flexible in picking whichever cloud you want. Because, okay, this month, here we got a good price. Next month, oh, they did a price reduction. Let's use this API. So, and again, this all is expressed as sources and sinks and flows. And you can always, if you have a sink, you can always get a subscriber from it. If you have a source, you can always get a publisher from it. So again, complete interop. So let's look at an example. How we envision building streaming apps or more integration apps. Because when people say streaming apps, it's also a bit confusing because sometimes they mean the data-heavy, analytics, machine learning-heavy pipelines, which usually is Spark or Flink or technologies like that, where they own the entire pipeline and they start the stream and they run the stream. Reactive Streams and Flow here is really more about the small jobs that have to be done and would be nice if they were streaming, and we don't have to have 50 nodes to do it. We can do it in a single node because that's actually sometimes faster. I don't know if you've seen, there were a few examples of people kind of comparing setting and grepping with Hadooping a problem. Setting and grepping would be simpler and faster, but yeah, we want to be enterprisey and use the big things, right? Maybe you don't need to use the big things. So, small side note. So how would I build a thing with Alpaca? You just pick, okay, I want to use Kafka streaming. I use that, include the dependency. Here I'm going to include Akka HTTP, just because I like it. Then basically you pick what source you want, right? So they kind of explain by the name what kind of semantics they have, and at most source and committable source. And they give you slightly different types. Here I aligned them a bit. And you can see, okay, you get a consumer record or you get a committable message. So with a committable message one, you're in charge of like hitting commit on each message. And then we do the cumulative to a given offset commit. And as I said, we have this outside control parameter that you can control this running stream and either get metrics out of it or stop it or pause it, things like that. So you picked one of those, and then you basically just need to, and I screwed up the slide a bit, but basically you need to connect some source to some sink. Basically, as simple as that, and that's an entire streaming HTTP app out of Kafka. You just pick a source, pick a sink, run the HTTP server, you're done. So this is a bit underwhelming to show perhaps, because okay, 3 lines, some magic. The thing is, it's actually not magic, it's very boring tech that just connects because we have the same types everywhere, and it just works because this undercovers agreement between these different libraries. But once you can realize that this is how I can plug stuff together, I think it's pretty, well, call it profit. And then you can just change the sources of things. It can be an FTP thing, can be whatever you want there, just works, trademark. And like I said, this Alpaca community, again, I would like you to use it with Akka, but you can use it with whatever you want. So, pretty inclusive. And last thing, that's something people don't often think about, is that the HTTP server can also be made streaming. How do we do that? We do that by expressing the HTTP server and the HTTP entity, again as reactive streams. WebSockets as well. I'll wait a moment because people are taking a picture. So the interesting bit here is this more precisely models HTTP2 than the server is a function, because a server as a function kind of implies one thing in, one thing out. A flow, a processor, can have one thing in, many things out. So that models the server push of HTTP2, where you get one request and you start pushing the assets right away. So, nice side effect. And then, again, buffers all the way down, as I said. And we basically propagate both the pushing of the data, that's all reactive streams, all the way to the TCP implementation we have, and other reactive libraries as well. And we propagate the back pressure all the way from the OS, from the windowing mechanism of TCP, into actually pulling more tweets or not. Literally, if TCP is getting back pressured because someone is in a tunnel and is not receiving data, we will stop pulling this stream. So it's also from that side pretty interesting. Again, how much code is that? Source, repeat a tweet. Okay, that's HTTP specifics, but that's basically path tweets, and then you complete it with these tweets as JSON. Some boilerplate, but not too bad. You start the server, you have a fully streaming HTTP server that will stop streaming the data to the client and basically emitting this new tweet load. Right? This could be a heavy operation, this could be pulling from a database or something. So it would stop invoking this thing if there would be no demand on the user's phone. So, pretty cool. Same thing in Scala. As I said, the two APIs are pretty similar. A bit more concise, but not too much. So you can stick to whichever you want. And adoption, right? So is this thing actually getting adoption from the big guys? Amazon's official SDK announced they will be basically exposing all of their libraries with reactive streams, and that again means they will be compatible with the JDK types. We already have a very exciting project in JDK 10, which is the asynchronous JDBC, which is finally coming, it seems. And of course, they'll be using those exact types, so that's a flow subscription, to give you streaming data out and into the database. So this is something I'm very excited about, because it was kind of long requested by many people. And also, I was a bit afraid because they wanted to ship it in 9, which would have meant they wouldn't have time to adopt the reactive streams thing, and it would be a streaming thing, but not reactive streams. Waiting for JDK 10 was actually a super good timing there, so they can use a kind of ready ecosystem and just jump right in. It's more of a slide about Akka and how the kind of complexity and power interact with one another. Basically, what I want to say is just don't use threads and logs directly, okay? If you think about, oh, I have this concurrency problem, and you start using the low-level primitives, okay, could be a fun project for evenings, but don't put that in production, because then we see just the wrong things, and there's better tools out there, be it streaming or actors or anything. So, yeah, we obviously have monitoring for this. The monitoring would be Akka stream specific, not flow specific. But is this thing ready to adopt in prod? Absolutely, because over the last 3 years we've seen big adoption of reactive streams. We know it's picking up. We've seen the big players adopt it. So it's only a matter of time of people hopping on to JDK 9 and being happy there. We have a conference that's focused more on the reactive side of things. So it's not a Scala conference. Sometimes people ask me that, being kind of related to the Scala ecosystem. It's a specifically reactive architecture conference. It's in 2 weeks from now. If you want a discount, let me know. And yeah, that's all I have. And if you have any questions, I'm not sure how we're on time. I think we're over time. But you can grab me, I have some stickers, or would be happy to discuss or answer any questions. So thanks a lot.